Hey, fourth grade, welcome back. I'm so excited that you're here. Um, just wanted to give before we get started with our lesson for today, I wanted to give some whole fourth grade feedback. Some great jobs I saw yesterday were just like really great canyons with their rock layers labeled. Some had fossils in it, which was awesome. Feedback that I want to give is that part of your assignment yesterday was to make sure that you had an explanation with that as well, why that canyon was deeper than the other. You should have had two canyons with a river flowing in between. Shout out to those friends that were resubmitting their work and taking the feedback that I was giving them. Shout out to you guys. Make sure you're always looking for that feedback. But before we get started, I want to definitely give some shine to some friends. Ava, Jaylene, Joshua, Leah, Brene, Legacy, Jada, Edward, Benji, Alan, Taylor, Amelia, Dylan, Giselle, Ariana, Uriah, Sheree, Zion, Zaire, Emery, Jesse, and Star. Shout out to those friends. They did an awesome job of making sure that they gave their two canyons rock layers, at least three rock layers. They were labeled with their canyon depth, and they gave an explanation of why. Some of those friends even had the challenge of the smiley face challenge of making sure, like, hey, I know that I watched Miss Clark's whole lesson video and I'm ready to go do my work. I'm also going to make sure that underneath my work, I have a smiley face. Shout out to those friends you guys had. And just not just those friends, other friends also made sure that they showed me that they did watch the whole video. By having that smiley face, that definitely shows me that you guys are such rock stars, and I'm very proud of each and every one of you that did that, even if your name is not on this list. I'm very happy that there are some friends that are on here that were not on here before. Very proud of the work that you guys are doing. And special shout out to Star. She definitely sent me a video of her project, her explaining each and every part of her project. That was really awesome. She went like above and beyond for that. Cool. So I want to just keep going. With that, these are some word samples. They're a little bit hard to read just because it was a picture sent in and then me taking a picture of that picture. So this first one says canyon number 1 is deeper because the faster the river goes, the more rocks break up and the erosion is happening faster. That was from Jada. Shout out to Jada and HU. That just pretty much really hit it down exactly why one of them was deeper than the other. While this one was canyon 1 is deeper because it has more water. So it can erode faster. That makes the canyon big, which was from Leah in Potsdam. Shout out to her as well, understanding that when it has more rock that's showing, that means that that water from the river eroded all those other rock layers. So that's why we're seeing so many rocks, different layers. That was the important part. Yes, a lot of you touched upon, oh, well, if you used 19 meters and 10 meters, and you were saying like, oh, like it was, this one had a larger, like 19 is bigger. Yeah, that's true. We're getting into the mathematical part of it, but why is that happening? That was the biggest part that I wanted to make sure that we were getting. Cool. Cool. If you have questions, please make sure you reach out so that we can make sure that we clear this up. So going on to today's lesson. Oh, I was also going to include Joshua F's response in there, but it just wasn't coming up clear enough for me to put into the slide. But his response was out of this world. I had to definitely shout him out in a comment. But what I want to talk about right now is we've been talking about how for a while now, since we started Earth's features, of that the Earth changes over time, right? And that we know that the Earth seems to change very slowly. And because we have a lot of sedimentary rock in the Earth, and we know that sedimentary rock takes a long time to form. But now there are some things that actually change the Earth rather quickly, and those are usually natural hazards or natural disasters. We're going to talk about one in particular. We're going to be talking about volcanoes, and we're going to be talking about earthquakes. So we're going to be thinking about what are natural hazards, what natural hazards are related to Earth's geology, and how might we protect people from their impacts. We started talking about natural hazards last Friday, and we're going to be building upon that now and learning more about those specific natural hazards. So I'm going to give you a second just to think about, and I want you to say out loud, even if there's no one near you, what you actually notice from what we're looking at right now. Yes, it's a map. But all of these are they look like these lines. I don't know what these blue lines are that are all connecting everything. They're these thick lines. Well, those are actually called plates, and we're about to get into that in a little bit. As you can see, it's kind of labeled as a Pacific plate, the Caribbean plate, the Antarctica plate, the African plate. There's different plates that are here, but we need to go into more of what those actually are. It kind of goes into this a little bit more. You can see them a little bit clearer now, where each of those plates are. Now, they're called tectonic plates, and they existed before humans did on Earth, right? And they cannot be seen. Even though we're seeing them on this map, that's just for our eyes and for us to have this understanding. However, normally you can't see them. And the continents, the mountains, the rivers, and even oceans are all on top of these tectonic plates, which you can see that there's some oceans over here on top of the tectonic plates. Then we have continents on top of the tectonic plates. And then, of course, we have some rivers inside here, rivers here. Mountains are definitely over here. And they're all on top of those plates. Now, what's the thing is that volcanoes and earthquakes happen when tectonic plates move apart and then together, or they grind against each other. Under those plates, there are a layer of earth called magma, which is rock that is hot and is practically kind of like a red liquid. And the plates float on top of the magma, which is how they're able to move. And this is what actually causes earthquakes to happen. So notice, we're looking at this map of the US. We're looking at our map legend or our map key, and we're seeing that a lot of these volcano eruptions are near where there are a lot of earthquakes. I wonder if that has something to do with it. Maybe. Now, we have this thing called a ring of fire. And you might be like, what in the world, Ms. Clark, is this ring of fire that you're talking about? Okay, well, we're about to talk about it. So the ring of fire is like a line right here. We can see it, right? And then there's some over here, but in particular, we're talking about right here. So the ring of fire is a line of active volcanoes. If you're connected, those dots, all these together, it would look like a huge circle, right? Kind of, sort of, little lopsided circle, but you know what we're talking about. And from there are volcanoes in the middle of this ring, right? There's even some right here. This is actually where Hawaii is. But all along here are volcanoes, but the one that's kind of like making it not a circle is the volcanoes that are here where Hawaii is. And those volcanoes actually formed Hawaii. And that was because like the lava from underneath the ocean, like they spewed together until the land was created. So and then it cooled, the lava cooled, which is actually pretty cool of how Hawaii is there now. So now what we're going to be doing, here's another little bit closer picture of seeing like that ring and seeing like the whole redness around and seeing it just a little bit clearer now than just this picture. This one goes in a little bit deeper into that ring of fire. And that's where those major volcanoes are happening. They can happen in other places, but the major ones, the ones that people worry about a lot, are happening there. So what you're going to be doing now is you're going to be going, and the link is actually inside the lesson right underneath this video. And you are going to be able to watch it's about 4 minutes, and then you have 3 questions to answer, and you'll just type them in. If it's easier for you to write out your questions and send them to me, be my guest, that's totally fine. Just make sure that if it's like a text or something, that you are attaching your name to it. But now that you show me that you watched this whole video, if you want to get an extra effort credit, you can send me a picture of a heart. You draw a heart and then you just attach it to your work, and there you go. And it's extra effort. Easy as that. Besides getting your participation credits for science, then you will also just earn that extra effort of just like, hey, I want to earn some more credits. I want to be one of those top paycheck people this week. I'm going to just draw a heart for Miss Clark, showing that I did do my part of my lesson. I watched the whole video. If you did that, I got you. I'll give you the extra effort. But if you do have any questions, back to the science lesson. If you do have any questions after you watch the video, make sure that you ask me. Either call me, text me, comment below, and I'll either be able to answer it, or I'll be like, hey, give me a call. But yeah, then you answer just 3 questions based upon what we were just talking about. And those questions are in the lesson for today underneath the video. And there's some pictures there too. Cool beans? Okay, guys, till next time.